Hello people, the question is from GATE 1993 exam. It's a 1 mark. First of all, let's have a look at the statement. It says, for the initial state of 0, 0, 0, the function performed by arrangement of JK flip-flops in the figure is. Then you have 5 options. They are option A shift register, option B mod 3 counter, option C mod 6 counter, option D mod 2 counter, and none of the above. Okay, so you can see I've drawn this diagram given in the question. We need to identify what kind of a counter is this. Okay, have a look. This JK is behaving as a D flip-flop. This one is also behaving as a D flip-flop. This one is also behaving as a D flip-flop. How can I say this? See, let's analyze this one. Whatever is connected to J, its complement is connected to K. And this is how we convert a JK flip-flop into a D flip-flop. See, if you have a JK flip-flop, then to convert this flip-flop into D flip-flop, we'll do one thing. We'll connect D input to J and its complement is connected to K. That means whatever is connected to J, its complement has to be connected to K, and whatever is connected here will be termed as D. Okay, so all of these are D flip-flops. Just have a look. For this one, whatever is connected to J, that means Q bar. Its complement is connected to K, that means Q. Okay, so this one is a D. This is clearly D, and similarly this one is also D. So all of these three are D flip-flops. So let me just redraw this diagram here. Okay, so you can see this is what we are actually given in the question. Okay, this output Q is used as input D for the next flip-flop. Similarly, this Q is used as input D for the next flip-flop. And this output Q complement is used as input to the 0th flip-flop. Okay, 0th, 1st and 2nd. Now you can see this is a Johnson ring counter. That means this diagram actually represents a Johnson ring or a twisted ring counter. Okay. So now twisted ring counter is an application of shift register. That means the given counter is a shift register. So option A is correct. And option C, mod 6 counter. This one is also correct. Because a Johnson ring counter or a twisted ring counter will be a mod 2n counter. N is 3. The number of flip-flops here is 3. 2n will be 6, that means it has to be a mod 6 counter, but we cannot declare it straight away. Okay, we need to actually draw this counting sequence or the truth table. Only then we can declare that it is a mod 6 counter, because we also have mod 2 counter in the options. I'll just prove what I'm saying. First of all, you just pay attention here. Let us do one thing. Let us actually name these outputs, or let us rename them. I'm writing Q2 here, Q1 here, Q0 here. Okay. So have a look. I told you this is application of a shift register. That means option A is surely our answer. So have a look. Whatever is this output Q2, that will be given as input D. Okay. And it is a property of D flip-flop. Its input will be just recorded as the new output. Okay, that means this Q2 will actually shift here. This Q1 will actually shift here. Okay, and the inverse of Q0 will actually shift here. Okay, so you can see the bits are shifting. See, Q2 will shift to Q1. Q2 will shift to Q1. So 0, 0, 0, 0. And 1, 1, 1, 1 will be copied as it is. This entire column has shifted. That means whatever bit was there is shifted here. Similarly, Q1 will be shifted to Q0. Okay. Now this is how a shift register works. That means bits are shifted and here you have the final output. The only minor change that we are making is this output is actually given as a feedback again to the first or 0th counter. Flip-flop actually. Okay. This entire circuit is a counter. All of these three are flip-flops. Okay. So we are just connecting the output as a feedback. Still it will remain a shift counter only. Shift register only. Okay. So what we are actually doing is Q0 complement will be copied as it is in Q2. So Q0 complement is 1 0 1 0 1 0 1 0. Okay. So this is the truth table for the given counter. Okay. So now let's find out the counting sequence for this counter. If a clock is given at this stage, that means if present state is 0 0 0, you will reach on state 1 0 0, that is 4. Okay. So if you give a clock, you will reach on 4. Then if you give a clock here, on 4, when you give a clock, you will reach 6. You have 6 here. On 6, if you give a clock, you will reach 7. On 7, if a clock is given, you will reach on state 3. Okay. And from state 3, if you give one clock, you will reach state 1. And from state 1, you will go back to state 0. Okay. Like this. So now you can see initial state that was given in the question is 0 and 0, 4, 6, 7, 3, 1. We have 6 states in this loop. That means this one will act as a mod 6 counter. Okay. Now there was a little confusion. Will the answer be mod 6 or will it be mod 2? Because this specific counter can be a mod 2 counter also. You can see 5 is missing. On state 5, we go to 2 and from state 2, we go back to 5. Okay. So I'm drawing it here. 2 goes to 5 and 5 goes to 2. This one acts as a mod 2 counter as well as a mod 6 counter. Okay. So, but answer is mod 6 only because initial state given in the question is 0, 0, 0. Had they given the state 2 or 5 as initial state, then it would be a mod 2 counter. Okay. Anyways, from here, answer is clear. It is a shift register as well as a mod 6 counter. Okay.